let's get started. I'd like to begin with taking questions from homeworks. Does anyone have questions from homeworks? Nick? Worksheet or problems? Okay.
Oh, you number 4 on the worksheet.
Worksheet, okay.
Worksheet 1. You got it. You got it.
So the directions ask us to use the exact or find the exact value using sum and difference identities. So I'm going to begin by looking at my sum and difference identities. And I notice that I don't see one for cosecant. So what I do see is one for sine. And I know using R4 from last chapter, I can rewrite cosecant as 105 as 1 over sine of 105. Now I can take that 105 and rewrite it as, say, like 45 plus 60. So I'm going to write it as the sum of two unit circle angles. There's more than one way you could do this. You could write it as a subtraction problem. You could use two different angles to add up, one positive, one negative, whatever. That's, I think, the most obvious choice. So now I'm going to apply the sum and difference identity SD1 because I have the sum inside of a sine function. Now I'm going to, at this point, go to my unit circle and find the values for sine 45, cosine 60, sine 60, and then cosine 45. Sine of 45 is root 2 over 2. Cosine of 60 is 1/2. Sine of 60 is root 3 over 2. And cosine of 45 is root 2 over 2. Which gives me 1 over root 2 over 4 plus root 6 over 4. Since those guys have a common denominator, I can write that as a single fraction. And since I have 1 over a fraction, that means I can just take the reciprocal of the fraction. Right, like last semester when we were doing like writing the sinusoids, if we had like 1 over 1/2, that was the same thing as 2. Same idea here. And so now all I need to do is rationalize my denominator. So because there's addition and subtraction there, I'm going to be using the conjugate. That's the same thing as the denominator, just with the opposite sign. And because Mr. Kulik can kind of see where this is heading, he's going to opt not to distribute the numerator out. When I multiply that denominator, I'm going to use the difference of two squares factoring pattern to kind of route my way through that foiling. You could FOIL it out instead if you'd like. We'll both end up at the same spot. The square roots and the squares cancel out, so I'm left with just 2 minus 6 in the denominator. Oops. Oh my goodness, Mr. Kulik. 2 minus 6 is negative 4. So those can reduce. Left with negative 2 minus root 6, or if I distribute the negative sign through, negative root 2 plus root 6. And again, all these are checkable, right? So if I did cosecant or 1 over, I guess we'll do sine of 105. And then I do root 6 minus root 2. I should get the same decimal. And I do, which tells me that my answer is correct. How's that feel, Nick? It's all right? So again, like, a little bit of the messy part was the cleanup, right? That algebra at the end to like rationalize our denominators and all that nonsense. But it wasn't so bad. It was regular bad. Other questions? All right. Well, let's start chapter 7 then. So to start, I want to remember something that we did in first semester. Well, let's do this first. We talked about solving triangles, right? That's a problem we've done before. When we talk about solving triangles, what does that mean? We have to find all the angle measures and all the side lengths, right? In semester 1, we did this for right triangles. The tools we used to do this was SOHCAHTOA and or the Pythagorean theorem, right? In semester 2, starting today, we're going to learn how to do this for non-right triangles. One of the most common mistakes students make when trying to solve a non-right triangle is they try to use SOHCAHTOA and or the Pythagorean theorem. Neither of those two things hold in a non-right triangle. If you don't know you have a right triangle, you cannot use the Pythagorean theorem. You cannot use SOHCAHTOA. Please be extra careful. I'm going to try to trick you many times over the course of today by suggesting to do one of these two things, and you need to make sure that you're paying attention and be like, no, Mr. Kulik, you can't do that here. I'm trying to trick you on purpose because I'd rather trick you now so that you don't get tricked later when it matters, right? Instead, the two tools that we're going to be using is something called the law of sines. I abbreviate that LOS, and the law of cosines. I abbreviate that LOC. We'll talk more about what those things are, here in a minute. But for right now, we're just going to leave it at just some names of these are the names of our two tools that we'll be using. Before we begin talking about either the law of sines or law of cosines, let's talk about the solving a triangle problem. So to solve a triangle, you need 3 pieces of information. Remember, back to semester 1, in a right triangle, you could either be given the right angle to make it a right triangle, and then 2 sides, or you could be given the right angle and then another angle and another side. Right? Those were kind of the 2 scenarios that played out in first semester when we solved the triangle. But either way, it was 3 pieces of information, right? Either 2 sides and an angle, or 2 angles and a side. One of the angles has to be a right angle. So the same idea here. We still need 3 pieces of information. In a non-right triangle, though, we can get 2 angles and 1 side. And that could look 2 different ways, right? So it could look like this. Or it could look like that. Everybody's okay there? Now, remember back to geometry. Well, I know that was a long time ago. You guys in geometry would have talked about triangle congruence. There are a bunch of triangle congruence theorems that were all named with 3 letters, like side angle side and stuff like that. Does that ring a little bit of a bell? That's usually something that sticks pretty good. We're going to name these different situations that we can have of starting information with the same 3 letters because it's really the same situation here. So if I look at the triangle on our left, how would I name that using those 3-letter naming conventions? Angle, side, angle. Great. Because if I look at this, if I read it counterclockwise, I have an angle, and then a side, and another angle. Right? The side has to be in between the 2 angles. Everybody's good? What would I name? Hi, Mr. Simmons. He is. Yeah, no problem. If we look at the other triangle, how would we name that one? What? Angle, angle, side. Good. Again, because if we read this counterclockwise, I have an angle, and then a side. Notice the side is not in between the 2 angles, right? So far, so good? Does everybody feel comfortable telling the difference between these 2 situations? One of our first steps in solving a non-right triangle is going to be the ability to identify which one of these situations we're landing in, because it's going to dictate what we do next. Okay? So really important that we're able to identify these things. So we could have 1 angle and 2 sides. And that could look 2 different ways. So if I look at that triangle on the left, how do we name that one? Side, angle, side. Again, if we look at these in a row, we have the angle in between the 2 sides. And then this other one we'd call side, side, angle. Again, if we notice we have 2 sides, but the angle is not in between the 2 sides. The third situation we have is you could just be given 3 sides. And there's only one way to do that, right? What do we call this guy? Nice try. Notice that there is no angle, angle, angle possibility. Why not? because 3 angles is not going to fix the side lengths to a specific number. Remember, like our 45, 45, 90 triangle? You could have side lengths 1, 1, square root 2. You could have side lengths 2, 2, 2 times the square root of 2. Side lengths 3, 3, 3 times the square root of 2. So in an angle situation, you don't have a fixed size triangle. You'd have infinitely many triangles that have those angle measures. We're not interested in that. So these are the 5 situations we can land in. Kate. Of course. So, if we are in angle, side, angle, 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 side, or side, side, angle, we're going to be doing law of sines. If we have side, angle, side, or side, 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 we're going to be doing law of cosines. Law of sines, yep, and then law of cosines. That's a good one to remember, right? That's how we're going to use the situation to help dictate what to do next. Everybody cool with the plan? All right. So let's write down what the law of sines is. In a different class, I might try to derive this formula. I'm not going to do that here with you guys. I'm just going to simply state the formula and you're going to accept it as true. Deal? Okay. Now, this is what we call the law of sines. Keep in mind when we're looking at this, this is actually 3 formulas in one. We could set those 2 fractions equal to each other. We could set those 2 fractions equal to each other. Or we could set those 2 fractions equal to each other. Does everybody kind of see how this is just 3 equations in one? Basically, you can take any one of these fractions and set it equal to any other fraction, right? That's basically all we're saying. In an effort to be compact, we just write it as one equation. Everybody's okay? All right. So let's look at some examples now. So we're given that angle A is 32 degrees, angle B is 73 degrees, and angle C is 13 inches, and we're asked to solve the triangle. The first thing I'm going to do is to draw and label a triangle. Now, when I do this, I draw all my triangles basically so they look the same. I'm not trying to draw it to scale. I don't care about my artistic skills. I never feel like it's worth the time and effort to draw it nicely. So I'm just going to draw all my triangles that kind of look the same. They're all going to look like these equilateral triangles, but whatever. So I'm going to label now the vertices of my triangle, A, B, and C. And now I'm going to name the side lengths of my triangle. Now remember, there's a method to doing this. If you do not name your side lengths correctly, you're going to get the wrong answers. So if you remember from first semester, we already kind of talked about that. So if this is my angle A, the side opposite that angle A should be named with little a. You guys remember talking about this? Okay, well, the side we name angle B, or the angle named B, the side opposite angle B should be named little b. And similarly, angle C, the side opposite angle C, should be named little c. Is everybody cool as to how we name our triangle? Critically important that you do this correctly. If your labels are not in the correct places, big problems.
So like angle side C, side.
What are you saying?
So like side C, yeah.
Side C?
Is the same, is equal to
No.
side AB.
I've just drawn it so it might look that way because I don't care about the scale. Is that okay?
Okay.
I just drew my picture. Like I always draw the same shaped triangle. I don't.
No, I'm saying like AB. So like line AB.
Oh, yes. Yes.
So they can be specified either way.
Yes. Yeah. The formula, though, we use this naming convention in the formula. That's why I making it a big deal to name it that way, because the formula names it that way.
Yeah.
So to use the formula, it's most effective to just, you know what I'm saying? Okay. All right. Now I'm going to add in the information that I know. So I know that angle A is 32, angle B is 73, and side C is 13 inches. Which situation am I in? There's 5, right? Angle, side, angle, 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 side, side, angle, side, 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 angle, side, side, side. Angle, side, angle, which tells me that we should be using the law of sines. Everybody's cool? On all of these solving triangles problems, we're going to be left to find 3 things, right? We're always going to be solving for 3 things. It may be a different 3 things on each problem, but always be 3 things. Among those 3 things, you're always going to be finding at least one angle. Everybody cool with that? Because there's no angle, angle, angle situation where you're given all the angles, so you're always going to be finding at least one. If you have 2 of the 3 angles, how do you find the third one?
So the last angle would be 180 minus both of those 2.
Excellent. So whenever you have 2 angles, the third angle is basically free, right? So in our case, angle C is 180 minus angle A minus angle B, which is 75 degrees. I'm going to add that into my picture. Is everybody okay there? As soon as I have 2 angles, I'm going to stop whatever my plan was to do next and find that third angle because it's basically free. It's just a subtraction problem. Does everybody feel good? Okay. I'm left to solve side A and side B now. To do that, I'm going to use the law of sines. To use the law of sines, I must know both the side A and the angle A, or the side B and the angle B, or the side C and the angle C. So my first order of business is I want to look at my picture and see which side angle pair do I know both of. In this case, it is C, right? Because I know angle C and side C. So I'm going to start my law of sines by saying sine of 75 degrees over 13. And now I'm going to solve for either side A or side B. If it's side lengths we're solving for, it doesn't matter which one we do next. So for the sake of the alphabet, I'm going to solve an alphabetical order. I'll find side A next. So the law of sine says I should write sine of angle A over side A. So there's my equation where I have one fraction equal to another fraction. What do we call that kind of an equation? Does anybody remember? Proportion. Excellent. How do we solve a proportion? Cross multiply. So we'll do A times sine 75 equals 13 times sine 32. To get the a by itself, we'll divide both sides by sine 75. And we're left then with a equals 13 sine 32 over sine 75. At this point, it's now calculator time. So we'll take out our calculator. What's the first thing we want to check before we start doing anything on our calculator? The mode. What mode should our calculator be in? Degrees. How did we know it should be in degree mode? The angle measures are in degrees. Excellent. So I'll check that real quick. Yup, I'm in degrees. So I'm going to press alpha and then y equals and pick the first option from the menu to get that horizontal fraction bar. And then type in sine 32 on top and then sine 75 on the bottom. Please, for the love of all that is holy, just type it into your calculator exactly like it looks on your sheet of paper. Don't get fancy. Don't try to chunk it. Just let your calculator do all the hard work. Just type it in like it looks like on your sheet of paper. And we'll press enter. And I get about 713. So if I go here to angle A, I know that's 713. To solve for side B, we can just use the Pythagorean theorem, right? Why not? It's not a right triangle. Oh, yeah. Okay. So what should I do to solve for angle B or for side B? Same thing, right? So we'll do sine of 75 over 13 equals sine of angle B, 73, over little b. Now keep in mind, I could have used sine of 32 over 7.13 instead of sine 75 over 13. That would be okay. I recommend against doing that because I'm a whole lot more confident that I subtracted three numbers correctly to get the 75 than I am I applied the law of sines correctly to get the 7.13. So why take the extra risk? I'm going to go with the answer I'm most confident with. Again, we'll cross multiply. So b sine 75 equals 13 sine 73. We'll divide both sides by 75. I'm just going to say the words and not write the work. Is everybody okay with me doing that here? Okay. As we go through and we keep doing these problems, I'm going to show less and less work. But the first time through, I'm going to, show it all, and then we'll talk it all, and then we'll just say what we're doing. To do this, I'm just going to take my previous equation, and I'm just going to change the 32 to a 73 because everything else is the same, right? If I look at this and I look at this, the only difference is a 32 instead of a 73, or a 73 instead of a 32. So that gives me 1287. Guess I should say inches there. So once I have that, I'm going to go back to the top and write that into my picture. And now I'm going to do one little check. We talked about this check first semester. What's the check that I do when solving a triangle? The biggest angle should be opposite the biggest side. The medium-sized angle should be opposite the medium side. The smallest angle should be opposite the smallest side. That all checks out. Now this check that we're doing right now is not bulletproof. Right? If you did something silly like you transpose that 7 and 8 here, this check won't catch that. But if you mislabeled your triangle or you put the wrong values into the law of sines or something, it should catch those kind of mistakes. Okay? I don't guarantee that it will, but it potentially could. Okay? Everybody so far so good? All right. Let's look at another example. This time, let's do angle P is 43 degrees. Angle Q is 80 degrees. And side Q is 7.3 centimeters. So again, I'm going to start by drawing my picture. What should I label the vertices in this picture? Yeah, just use the alphabet, PQR. So I know the side opposite P is little p, the side opposite angle Q is little q, and the side opposite angle R is little r. I'll fill in my values. Angle P is 43 degrees. Angle Q is 80 degrees. Side Q is 7.3. Which situation did I land in here? Yeah, angle, angle, side, or side, angle, angle. It doesn't really matter which way you call it. Everybody's okay? Tells us that's the law of sines. Again. Notice that we have 2 of the 3 angles, so what should we do right away to start? Find the third. So 180 minus 80 minus 43. So that's 57. And I'll write that in. We're left to solve for 2 side lengths, P and R. To do that, we're going to use the law of sines. Should we be using angle P over side P, angle Q over side Q, or angle R over side R to start? Should be using Q, because that's the one I know both the side and the angle with, right? So that should be my first ratio. Now, the side that I solve for next, Q or R, does not matter. If it's a side length you're solving for, the order doesn't matter here. So I'm going to just use the alphabet. We'll do P first and then R second. I don't know, alphabetical order. I like doing that. You don't have to. It doesn't matter. You could have done R. So I'll write sine 43 over P. I cross multiply and divide. Can I do that all in one step? Is everybody okay with me doing that? Save us all a little bit of writing. Well, all of us that are writing things down anyways. Everybody's good with that? Do the cross multiply and divide in your head real quick to see if I put everything in the right places. I know I did. I'll go and type this into my calculator now. 7.3 sine 43 divided by sine 80. I get 506. So far, so good. To find side R, I'm going to repeat the same process. So again, I'm doing sine 80 over 7.3. I especially don't want to switch here because both those values were given for me, so I definitely can't have screwed that up. And then I'm going to have sine of 57 over R. And again, I cross multiply and divide. So I have 7.3 times sine 57 divided by sine 80. Again, I'm doing the cross multiply and divide all in one step. If you are not comfortable doing that, write out more work. You don't have to be fancy. You don't have to do it all in one step. Mr. Kulik's done like literally thousands of problems like this, so he feels really, really comfortable with the process. If you're not there, do the cross multiplication step as a separate step. Do the division as a separate step. Make sure you have the things in the right places. And that is 6.22. My last step is I'm going to go back up here and fill those in. And just double check that the smallest angle is opposite the smallest side, the middle-sized angle is opposite the middle-sized side, and the biggest angle is opposite the biggest side. That all looks good to me. You guys agree? Best we can hope for. All right. At this point, we'd be finished with section 7.1. I'm not going to do 7.2 right now. We're going to do 7.3, and then we're going to come back to 7.2. I think 7.2 is the hardest part of this chapter. So I'm going to save that until you've had a little bit more practice, like actually solving triangles before we go back and try to do 7.2. In 7.3, we're going to be looking at the law of cosines. So again, if we have just some triangle ABC, the law of cosine says side A is equal to, or A squared is equal to B squared plus C squared minus 2BC cosine of angle A. Or B squared is equal to A squared plus C squared minus 2AC cosine of angle B. Or C squared is equal to A squared plus B squared minus 2AB cosine of angle C. Again, notice there's three versions here, just like there was for the law of sines, but there's not a convenient way to write it as one formula. If I look at these formulas, though, what do they kind of look like? Looks like the Pythagorean theorem. It just has like this extra correction factor at the end. If we were to derive this formula, we'd be using the Pythagorean theorem as like the foundation for that derivation. We will not do that in this class, but that's the takeaway, is that this looks like the Pythagorean theorem with a correction factor at the end. Okay. Let's do a couple of examples. Find my numbers here. So here we're given that angle A is 34. Side B is 14. Side C is 17. So again, I'm going to draw and label my triangle. I'm going to add in my given information. What situation am I in here? Side angle side. So that tells me I should be using the law of cosines here. So if I look at my given information, the only angle I'm given is angle A, which tells me I should be using this version of the law of sines, the one with angle A in it. So I can say that A squared equals B squared plus C squared minus 2BC cosine of angle A. Or if I fill in the values for my problem, A squared equals 14 squared minus 17 squared minus 2 times 14 times 17 times cosine of 34 degrees. Please, for the love of all that is holy, just type that into the calculator the way it looks. Don't chunk that and do like 14 squared and write down the number, and write plus 17 squared and write down the number, and then do 2 times 14 times 17 and write down. Because what's going to happen is you're going to add those two numbers together and subtract the third number, and you can't do it that way because you forgot to multiply the cosine in, and you're going to end up getting the wrong answer. Just type it all in one line into your calculator, please. That's the way that Mr. Kulik would do it. That's the way you should do it. It'll get you the right answer. Don't try to overthink it. Just type it in the way it looks it on your piece of paper into your calculator. So I get 90.38. No way, Mr. Kulik. Side A is not 90.38. Yeah, what did we find here really though? We found A squared, right? So what do we still need to do? Square root both sides, right? So I'll do square root, and then I'll press second and the negative sign. That's the ANS command. That just, the calculator fills in the last answer it got. And I get 951, which seems a whole heap better. Everybody feel good? So far, so good? Now I'm left for solving angle B and angle C. The order in which we solve our angles does matter. In this case, we need to find the smaller angle first. I'm going to write that real big. So look at our picture here. Which one is smaller, B, angle B or angle C? How did you know it was angle B? How did you know it was the smaller one, though? That's correct. Great, because the side B is smaller than side C. Is everybody good with that? Okay. So to do this now, I'm going to use the law of sines because I think that's easier to find the missing angle than using the law of cosines. So I'm going to do sine of 34 degrees over 951 equals sine of angle B over 14. Everybody good with that setup? Again, I knew that because the only pair that I had was side A and angle A, right? That's the only pair that I knew both the side and angle for. So we'll cross multiply and divide. That gives me sine B equals 14 sine 34 over 9.51. But how do I get that, like, that sine out of there, right? I gotta get sine out of there. Instead of sine B, I want just angle B. What's going to cancel out that sine in the front? Who remembers? Yeah, sine inverse. So we just do sine inverse to both sides. So we get B is equal to sine inverse of 14 sine 34 over 951. Again, please do this all in one line on your calculator. Don't make this harder than it needs to be. Type it in exactly like it looks. So sine inverse, second sine. Alpha y equals option 1, 14 sine 34 divided by, I'm going to do second and then the negative sign to get the ants in there so I can just plug in the 951 and take all the decimals with me and then enter. So I got 55/44. So far, so good? How am I going to find angle C now? Yeah, I just found my second angle. So yeah, I can just do 180 minus the other two. Don't do more work than you need to. Could you do the law of sines again on this thing? I mean, I guess, but like, don't. Don't. Do it the easy way. So I get 90/56. So I'll go and add those into my picture here. And then what do we notice? In our check, it all looks good, right? So far, so good. I got one more example to show you today. So let's say side P is 5, side Q is 8, and side R is 10. Now, I don't even need to draw a picture here to tell what situation this is. What situation has this? Side, 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 right? You're just given 3 sides. Durr, Mr. Kulik. However, in the side, side, side situation, we have to be careful. Because not every 3 numbers actually represents a triangle. If I told you the side lengths were 1, 1, and like 10,000, well, that can't make a triangle. You try to like 2 little ones and then something 10,000 long, like you're never going to be able to hook that together and make a triangle. So we have to check to make sure a triangle is possible. So again, be careful. Does anybody remember how to do that? Pythagorean theorem need not hold because it's not necessarily a right triangle. But you're close. The sum of the legs must be greater than the hypotenuse. That's our check. Mr. Kulik, how can I tell what's a leg and what's a hypotenuse just from looking at the numbers? Yeah, the biggest one is the hypotenuse, right? Does it matter which one I call which leg? No, man. Is 5 plus 8 bigger than 10? You betcha. So this problem is doable. If you found that to be false, you would just say there is no triangle and you're done. There's nothing more to do. Everybody's cool? Okay. So let's draw our picture then, since we know it's possible. So PQR, PQR, P is 5, Q is 8, R is 10. We identified that this was SSS, so that we need to do law of cosines here. The order we solve for angles always matters. In the case here where we don't have any angles yet, we want to find the biggest angle first. Which angle is the biggest angle, P, Q, or R? R. So I would write little r squared equals P squared plus Q squared minus 2PQ cosine of angle R. The way that I remember this is just that whatever letter is equal to is the same letter for the angle in the cosine. And then everything else is just like, doesn't matter where the order the other two is, whether I wrote Q squared plus P squared minus 2QP, or what I wrote here, it doesn't really matter. Everybody's cool? All right, we're going to be solving for angle R. To do this, what I'm going to do is I'm going to solve this, rearrange this formula symbolically, and then plug the numbers in, because I find that students are less likely to make a mistake if they leave these as letters than if they make them numbers. So to get that angle R by itself, I'll start by subtracting p squared from both sides. Everybody's okay there? Then we'll subtract q squared from both sides. So far, so good. And then we'll divide by negative 2pq to both sides. And then to get rid of that cosine in front of our angle R, what do we need to use? Cosine inverse. So we'll do that to both sides. So I have that angle R is equal to cosine inverse of R squared minus P squared minus Q squared over negative 2PQ. Now that I've rearranged my equation, now I'm going to put my numbers in. So cosine inverse of 10 squared minus 5 squared minus 8 squared over negative 2 times 5 times 8. And if you haven't been listening to me before about just type in your calculator the way it looks like on your sheet of paper, please do it now. This one, so many students get it wrong because they, even though they have the right stuff written down here, they can't get into their calculator correctly. So cosine inverse, alpha y equals option 1 to make my fraction, and then 10 squared minus 5 squared minus 8 squared over negative 2 times 5 times 8. Enter. 97.90. Is everybody okay with how I got that into my calculator? Again, not difficult to do it that way, but like so many times I see students like just not going that route, and it makes a problem. So if I go back and I write this in now to my picture, and if I look here, that looks like a side angle side situation where I'm left to solve the remaining two angles, right? Remember, in the side angle side situation, to solve the remaining two angles, we have to find the smaller of the two remaining angles next. So again, I have to be careful here. The order that I solve the angle is matters. I should say can matter. Sometimes it doesn't. So again, so between P and Q, the smaller angle is P, since side P is 5 and side Q is 8. So I'm going to set up my law of sines. I'll say sine of angle R, 90.97, over 10 equals sine of angle P over 5. I cross multiply, I divide, and then I do sine inverse. I'm going to do that all in one step. Again, if you're not comfortable doing that all in one step without showing any work, you don't have to do it that way. Feel free to do it in several steps. That is okay. Mr. Kulik is confident that he can do it correctly in one step. That's why he's doing it that way, and I've shown you how to do it correctly using more than one step a couple of times. I'm just sick of actually writing everything down again. Again, all in one line in my calculator. So 5 times sine, and then I'm going to do second and the negative sign to grab that previous answer, that 90.9 or 97.90. Ooh, boy, wrote down the wrong number there, huh? Yikes! Press enter, so that's 2969. Let's go back and change those. I did it up here too, huh? Okay. Yikes! It's angle P. How am I going to find angle Q? Well, I'm just got two angles now. So I'm just going to subtract those from 180. And I get 5241. How do you guys feel? So the hardest part is remembering what order we have to solve for the angles when you have to solve angles, right? In general, you know, like if you have three angles to solve, you do the biggest first. If you have two angles to solve, you do the smallest. That's the rule. And if you write it that way, it's not so bad. But I get it. There's a lot of like things you have to be careful about here. And we haven't even gotten to the worst situation. We've done angle, side, angle. We've done angle, angle, side, angle, side, and side, side, side. If you remember back to geometry, all four of those were congruence theorems. We haven't done the side, side, angle. If you remember back to geometry, that is not a congruence theorem because that specific assignment of values doesn't guarantee that the two triangles have to be the same. So in our case, it means some cuckoo things can happen. We'll deal with that next time and just talk about that one situation and how to handle that one situation next time. That'll probably be the whole class, talking about that one situation. But that's what's going on here. And that's the reason that we need to be careful about the order that we're solving these angles, is we don't accidentally stumble into a side-side angle situation that's giving us like weird things happening. That's why we're being careful with our angles, is that we don't accidentally end up with something that we can't deal with, or that we're going to get the wrong answers for, because here's the terrible part. Some side-side angle situations have two sets of answers. Oh, we'll talk more about that next time. At this point in chapter 7, you guys should be able to do numbers 1 through 4, and then numbers 15 to 22. Remember from chapter 6, we've already assigned 1 through 10, and then I think it was 23 to 26 and worksheet 1. That's the stuff that'll be the stuff for Sunday. Anything we do on Friday wouldn't be due till the following week. Is everybody okay with that? You know what? We can even, we don't have school on Monday, do we? Let's call that Monday. Right? Be due Monday at midnight. Because I won't look at it till I get to school on Tuesday.
Tuesday morning.
Just being completely honest with everybody. Let's be real. Mr. Kluck's not staying up till midnight to check homework. Nope. He just looks at it the next morning when he gets here. So, if that helps any, take an extra day. Doesn't bother me. Any questions about any of this? About when things are due, or what's due when, or what we're doing next, or what we did today? Okay. Overall, this is seeming okay so far. Not terrible. It should feel, the nice part about this is that like it's all kind of the same. So like once you've got it, you can kind of just do it because the problems aren't, one problem is not really markedly different than the other. Because the sub skills to like do any problem are the same, right? It's just like, okay, this problem I need to do this order instead of that order, but it's like the skills inside are the same skills. You know, like the way you find the pieces is going to be the same all the time, which is nice because they're all kind of the same then that way. And just making sure you know, like, what scenario have I landed in? But yeah, that's kind of the gist of it. I'm done here, you guys. So I'm going to stop talking now and end the recording.